Okay, can everyone see that? Great, okay, very good. So I'm Heather Clark. I now am at Rocky Mountain Institute as of May, but prior to that, I did a lot of work in affordable housing in Massachusetts on the development side. I created Wind Company's Green Building Program in the mid-2000s, and I also led Castle Square Deep Energy Retrofit. And then most recently, and then about 10 years ago, I formed my own company, Biome Studios, where I've been working on lots of different projects, including this one, which is Moran Square in Fitchburg. This is currently under construction, and I started at RMI at the end of May, and this started construction right after I left. So the timing was good. And what I hear, things are going well at the site. It's always a little nerve-wracking to leave a project, but things go on. So, and now, by the way, I work at RMI. I manage Realize, which is our deep energy retrofit accelerator. And I also work on federal and local policy as well. Okay, so Moran Square in Fitchburg. It's a beautiful historic property right downtown Fitchburg. It includes a firehouse on the left, a vacant lot, and then a commercial building that's 3 stories. And on this project, we're going after not just, it's not just an affordable property, but we're going after federal historic tax credits, which makes it much more challenging to achieve these goals. So I wanted to do a shout out for our team. Reese Larkin, development, John Rosinski is the developer, TAT is the architect. I served as part of the development team and led the whole passive house decarbonization strategy. Peterson Engineering is the MEP. Building Science Corporation, CODA is the building scientist on the project. New Frameworks, Jacob Bratt-Cusin served as the low embodied carbon consultant. And then Advanced Building Analysis is the PHMass rater. By the way, Peterson Engineering is the passive house consultant. And then finally, Keith Construction. All right, so everyone on this call, I'm sure, is pretty familiar with passive house. And those of us in the efficiency community and have worked on passive house for a really long time, we've done a pretty incredible job on this building operations side. Building operations of climate change is about 28% of CO2 emissions. It has to do with building operations. Where we've kind of lagged, and I have to say I have as well, is on this building materials and construction side. 11% of global CO2 emissions are attributed to building materials and construction. This is huge, and we need to deal with it now. On this project, we're dealing with both building operations through passive house and then building materials and construction by specifying really low embodied carbon materials. So as we talk about passive house and how we approach this next phase of our journey, trying to get to solutions that really address this climate crisis that we are all very much in the midst of, we cannot be doing this to our buildings. I, as many of you have probably done as well, have done a lot of foam on my buildings, and it's not the answer. We've got to be using low embodied materials going forward, starting today. And I challenge all of you to really think about how you can do that with your projects. The reason why this is so important, this came out from Carbon Leadership Forum. It shows the years of a building life. So you can see annual operation of carbon caused by how much energy we're consuming through the operation of our buildings. It goes along for the length of the whole period of the building. And that lasts the life of the building. The scary thing, though, is the day that you build that building, you have a huge amount of upfront embodied carbon. Given where we are with the climate crisis, we cannot be adding this giant pulse of carbon emissions right when we build all these buildings or right when we retrofit our buildings. We got to think about this from day one. The exciting thing, though, is that when we embark on a building project, the first thing we should do is consider whether or not new construction is even needed. The exciting thing is that the embodied carbon impact of redeveloping an existing structure is 50 to 75% lower than the impact of constructing new. If we are able to retrofit our buildings, we are so much further along on addressing climate change. And I think that this is an area we really need to be focusing a lot of energy an effort is like, how do you redevelop? There's also just like all these social benefits to redeveloping existing buildings in terms of, connection with neighborhoods and feeling like a cohesive place. So there's lots of benefits. And I need to mention RMI recently did this really great report looking at analyzing low embodied carbon materials. And I can share that with all of you after this presentation because I think it's a really helpful resource. Okay, so how do we approach this goal at Moran Square, which I'm calling decarbonizing Moran Square? Well, the first thing is we leverage the embodied carbon of these existing buildings. We're also reducing operational carbon through PHMass passive house. And then we are also using low carbon and carbon storing materials for the structures that we're building. So here's the site, right downtown Fitchburg, Massachusetts, and we have this existing firehouse. We have an existing 3-story commercial building, and we have a vacant lot. We're right by the train station. It's a walkable neighborhood, and it's an area that really needs investment as a gateway city. The firehouse is beautiful, historic. We have a vacant lot where we're going to be building new construction, 5 stories, and then we have this commercial building. And what we're doing here is we're going for federal historic tax credits. So these projects are regulated by National Park Service. We believe that we are probably the first passive house project in the US to get federal historic tax credits. There could be others. I know that others have been attempted and made really good efforts and haven't got there. But this could be groundbreaking for a passive house if we can achieve this. This is the new building that will be in the middle. So let's talk a little bit about carbon storing materials and what that looks like. So embodied carbon is the sum impact of all the greenhouse gas emissions attributed to materials throughout their life cycle. We can reduce, this is that study I mentioned about reducing embodied carbon in buildings. I'm going to refer to it a few times. It just came out through RMI where I work recently, and I found it incredibly optimistic in terms of what it's showing of how impactful we can be with embodied carbon. So this is the conclusion of that report. They looked at all of these case study projects, and what they discovered is that on mid-sized buildings, you can reduce embodied carbon by 46% for less than a 1% cost premium. That blows my mind. If we could really do some simple changes in how we're building our buildings, we could be achieving these really deep carbon savings for very little cost. So what does that look like? Like what types of improvements can you make on the embodied carbon that's not that hard to do and not that expensive? The first is optimizing your concrete mix. And from that, we're seeing and this, by the way, I am sharing some general data from the RMI report. This is not analysis that we did for Moran Square. Because we actually didn't have funding to do a really deep dive at Moran Square into the results of the embodied carbon work that we're doing. We just created goals that, and we're specifying to those, but we didn't do any kind of like overall analysis. But what that RMI study is showing is optimizing the concrete mix makes a huge deal. Using high recycled content like rebar also makes dramatic reductions in carbon, very little cost. Selecting low or no embodied carbon insulation products has a 16% reduction in carbon at a building. Glazing low embodied carbon materials, 3% reduction. It does have a cost premium. And then finished materials, a 5% reduction with little to no cost premium. So this is, how do you go about this using materials that are currently available? In terms of embodied carbon and thinking about it, different materials have a larger greenhouse gas emissions. So depending on what the materials are, like for example, cement, steel, you're creating quite a large amount of carbon emissions. What's really exciting though is when you get into this negative area, these materials are actually can potentially be storing carbon, like straw or mass timber or other materials. Similarly, on insulation at Moran Square, we actually outlawed XPS. We said we're not using it. Even under the foundation, we're using a product called Glavel, which is a recycled glass product that acts like almost like gravel, but is also insulating. We said we're not doing XPS anywhere. And instead, we're focusing on insulation like cellulose, which has which actually can be carbon storing. If you're thinking about what materials, like in terms of like your instinct, what materials are low carbon or carbon storing, I really like this like as a carbon storing materials palette. Think about natural materials. Those of you like myself, I don't know how many of you are out there, but when I first became interested in green building in college, like in the late 90s, I was really interested in the whole natural building movement. I did a lot of straw bale workshops and I did a lot of work with my hands. And those materials that we were using then, this natural building materials, actually are what we need now, even for these large buildings. So let's think differently about materials. And you can be looking at environmental product declaration of materials, and there's other methods to try to get a better analysis. And then, of course, concrete. 8% of our global greenhouse gas emissions are caused by concrete. So the first thing that we're trying to do at Moran Square is utilize materials. The next thing in terms of our strategy here is concrete. We try to increase our fly ash and reduce Portland. On the insulation side, we use cellulose mainly, some mineral wool, some eco-fiberglass, and then gravel, that recycled glass component. We did have to use some foam in a parking garage ceiling, but we specified a low HFO foam. And then for the studs, we specified wood instead of steel, which actually makes a considerable difference in carbon. However, as all of you have been probably going through the same thing with COVID, the price of wood has gone through the roof. So the last I knew, as I was leaving, there was this big debate whether or not we should be going to steel studs. And it looks like they went to steel studs, which is kind of a bummer. But hopefully on future projects, the price of wood will get more in control and we could do wood instead of steel. On flooring, our goal is to reuse as much wood flooring as possible. We also use marmoleum. Interface LVT offers a zero carbon LVT. And then for sheetrock, we use an EcoSmart sheetrock, which has high recycled content. Okay, so let's talk, that's embodied carbon. We need to be doing it. Let's talk about how we got to passive house in this historic building, which is really hard to do. And then I'm going to talk a little bit about solar. All right, so I said it's really hard to do. I guess it's not always that hard to do. I think it's like being one of the first is the hard thing to do. It's going to be easier, I think, for all of you if you try to do this in a historic building. So a few principles of passive house, which I'm sure all of you are familiar with, but I'll just say it in case there's some newbies on the call. The first is that we need continuous insulation without thermal bridges, which is harder to do in an existing building. So we'll talk about how we did that. And we were allowed by PHMass some thermal bridging. We didn't go in and cut, where the floor connects to the wall, but we really minimized thermal bridging. Airtight, these buildings have to be airtight. High performance windows and doors. This is a huge issue when you're doing a historic retrofit project because National Park Service, who regulates these federal historic projects, are very restrictive on what kind of windows you can use. So I'm going to talk about that. That's like our breakthrough. We need heat and moisture recovery ventilation, and then the result is minimal space conditioning. So in terms of our air barrier, where do you draw your run line on the plans? For our project, there was a lot of discussion early on with PHMass whether or not we should be separating out the historic buildings or whether or not we should include this new building. How do we do this? At one point, when it looked like we might not be able to use the type of windows that we wanted to use, we even thought about not doing the historic buildings as passive house. In the end, we did this air barrier that combines all three of the buildings because they're acting as one big system that is a central system for heating and cooling that supplies all of these units. So in terms of whether or not you should embark on the challenge of a historic tax credit project and try to achieve passive house, let's look at three things that can help you make that decision. The first is simple architecture. I would not attempt to do passive house on a really complicated structure. What we're dealing with here are more like boxes, and that makes it a lot easier to achieve passive house. They're a box. The second is the windows. These windows here are 1/1. They're very simple. If it was a really complicated window, I don't think you could, I think you'd have a harder time replicating it as a window that's going to work for Passive House. The other is that we had limited interior exposed brick. The National Park Service often asks that you keep exposed brick if it's there. Fortunately, in this case, we didn't have a lot of exposed brick, so we were able to insulate, do a really good job insulating on the interior walls. Okay, so some of the guidelines that made it more challenging to achieve Passive House. The first is windows. As you know, Passive House projects need casement windows to meet air infiltration. These weren't casement windows, so what do you do? So that I'll talk about that. Wall section depth, we were limited by National Park Service how deep our wall sections could be. We wanted to go deeper, and they really limited how deep those could be. In some locations, we were required to have exposed brick. Other places, we couldn't get rid of thermal bridges. And PHMass worked with us, and we did a lot of analysis to make sure we didn't have any condensation issues or other long-term problems. But they turned out to be not that big a deal. And then, of course, nothing visible from the exterior. You can't be doing penetrations in the walls or anything else because this is a historic property. And then finally, on the new building, we were actually required to have a brick facade. And I need to note for all of you specifying new buildings, brick has a really high climate change impact. And we need to think about whether or not we should be using brick. And if we do use brick, what type of brick we should be using. And so we were required to use brick on that new building. Okay, so let's talk about windows. These windows are 1/1 windows. Fortunately, National Park Service agreed that we could replace all of the windows. They felt like they were in poor enough condition that new windows were okay. So our next step was figuring out, well, what kind of windows can we use instead of a double hung window. I did a lot of research, like a huge amount of research. I basically spent a summer talking to every window manufacturer out there. And what people are doing now is creating these simulated double hung casement windows. In this case, these are windows for this diagram's from Zola. We didn't end up using a Zola window. But this is how the windows work. They look on the outside like they look like a typical double hung. On the inside, they're a tilt and turn window casement. Huge benefit. We're doing triple pane on this project, and it is a huge benefit for air infiltration to do this. Now, to get National Park Service, to our knowledge, has never approved a simulated double hung casement window. So we spent about a year working with National Park Service on this, where we had them look at a series of manufacturers. They did a really comprehensive analysis of all like the details, how deep our meeting rail were, and all sorts of other things. And then they gave us guidance on, very informally, on which windows they thought might work and might not work. And we ended up going with a Yarrow window. And Yarrow's they worked with us. This is a demo where we were experimenting. And even when we installed those Yarrow windows as a mock-up, we realized that they didn't look good enough. There was too much reflection. They weren't really tight enough. They didn't look enough like the existing windows, and they had more of a shadow. So we had to even do more back and forth with them. So I'm saying all this not to scare you, because I'm sure it sounds a little intimidating to spend a year like just working on the windows. However, the exciting thing is that National Park Service is really looking at Moran Square as a national model. If this project looks good, approving and getting approved simulated double hung windows are going to be so much easier for future projects. National Park Service told us that they also have climate change goals, and so they're looking for answers. So I'm really excited about that. So I hope our path is going to make it easier for all of you folks to do these projects on historic buildings. So this, again, our solar heat gain coefficient was true reflective. We ended up making it less reflective, which caused a penalty in terms of, now we need more air conditioning. However, the difference wasn't too bad, so we could do that. We also, it was too bulky. We had to experiment with installation. Meeting rails had too much shadow. So these are all the things like down to like an 1/8 of an inch that we were considering. Okay, so that was the windows. The windows are huge in terms of a major breakthrough for these types of buildings. The next is wall section depth. National Park Service and down on the first floor of the firehouse is requiring that we keep some of the exposed brick. So that's an energy penalty right off the bat. The other thing that they're asking for is we have, the one good thing is we have these attics. So we actually can just do standard cellulose blown in insulation with air sealing, which is exciting. But the other thing they're asking for is that we're only allowed to build up the wall section of these existing walls by 4 inches. So you have the existing brick. We are allowed to strip down the plaster and lath, but then we're only allowed to build up 4 inches from the surface, the current surface of the plaster and lath. So we have about 6 1/4 inches to play with, which, as you know, if you're trying to do like your perfect passive house wall section where you can't do exterior insulation, you really want more than 6 inches. So we had to do some magic. Now, if you're doing foam, it's not that hard to do it within this scenario, but we said we're going to try not to do foam. So we made it really hard. Like I brought Coda from Building Science on the project early on and said, Coda, can you join me on this quest to try to come up with like the historic foam-free wall? And he said yes. And so it's a lot of fun trying to figure out how to do this. So what does this look like, this foam-free insulation air sealing wall? Well, one of the concerns that if you've seen in Building Science presentation is you have this risk freeze thaw. If you get any kind of moisture onto these walls, there's not good drying potential. So air sealing becomes incredibly important, or you could have long-term damage. So if you're doing a spray foam application, it's pretty easy. We did this at many years ago. It was Coda and my first project together. I think it was like 2007 or something, and we did a mill in Boston where we were so proud of ourselves. It was LEED Platinum, and we used closed cell spray foam, and it looked a lot like this. So we did closed cell spray foam, and then we did stud wall, and then it looked like a lot like this. And it was a great model. You're not going to get air leakage. However, you're using a lot of foam, and if you look at the data, closed cell spray foam has a huge global warming potential. So what we ended up saying is we're going to try something different here. So this would be our ideal situation. We do a liquid applied air barrier, we do rock wool, and then we do cellulose insulation as well in the studs. However, we just didn't have the space. So in the end, what we would have liked to do is we would have liked to do smart vapor barrier here. We would have liked to do some strapping to protect that vapor barrier, but we weren't allowed to do that because of the restriction of National Park Service. This would be an area where it would be a really help to the building durability if National Park Service let us do that wall a little thicker, and maybe in the future they'll change their opinion on that. So what we end up doing here is we're doing a vapor semi-permeable fluid applied air barrier directly on the brick. Then we're doing our mineral wool. And then we're doing on top of the mineral wool a variable perm vapor retarder, and which is important in terms of not letting that water get into this wall, the brick wall. And then finally, we're doing cellulose insulation in our studs, and then the gypsum is attached to that. And that's all because if we had done strapping, it would have made this process a little easier. Because the real trick here is how do you get that vapor retarder, this membrane on top of the mineral wool. It's a trick that I haven't seen in the field yet. We're gonna have to do that mock-up. I think it's this winter to figure out what that's gonna look like, but I think it's gonna be really hard. If we were instead allowed to do strapping, it would have been a lot easier. Okay, and then the other thing that was a big win for us is instead of using XPS under the slab, we're using Glavel, which is a recycled glass product that has an R value, and it also doubles as gravel. And right now, Glavel just opened a plant in Vermont, so we're able to get that more locally. Another area that's a challenge here is the storefront. We're required by National Park Service to keep the existing storefront. So with some repairs, so what we're going to do is actually build like a new internal wall inside of that, internal glass wall inside of that storefront. But again, these are some of the compromises you have to make to retain the historic character of the property. Okay, and then solar. This is looking outside of the wall, outside the window at our neighbor, and it turns out this site is really great for solar. So we are using, we're doing, actually now it's 120 kW solar installation. Sunbug is the solar installer here. And we are right now not maxing out the entire roof area. I'm going to explain why, but Hank specifically said, please talk about what we could have done to get to net zero. And as I looked at it, I was a little frustrated that we're not at net zero because I feel like we're actually pretty close. So one of the constraints was that one of the buildings is that firehouse, and given the orientation of the sun and shading, putting solar on that firehouse wasn't optimal. The other thing is that firehouse, National Park Service, it's very important to them. Like it's a very, all these historic buildings are important, but it's a really special building. It's really small. It's very well intact as a firehouse. So adding solar there was a chance it could be seen from the street, which is a no-no for National Park Service. So we just didn't put solar there. So we focused on the new building and the other 3-story historic building. So what does our solar look like? What are the results here? Well, we have 122 kilowatts of DC solar, which is about 86 kilowatts AC. The solar output was designed to match the house electric demand. So we're at net zero for the house meter. But again, that's not enough to get to total net zero. So let me explain what's on here. The house meter has all the electricity for the ventilation system, common area electric lighting, plug loads, and almost all of the space heating and cooling. I need to note that we are all electric except for our hot water. And now that I'm working on RMI and I'm learning the importance of electrification, I really question, I mean, it was something I questioned from the beginning of why we're not electrifying the hot water. But we chose not to, and most projects that are passive house, as you know, in Massachusetts, don't have their electric hot water. It's not electric hot water. And that's because the cost of gas in Massachusetts is so much cheaper than electric and can really hurt these projects. So that's a whole other problem that we need to solve, is that that price of electricity for these projects. And I think that's something, as an aside, from a policy perspective, we could be doing a much better job on the rate structure for electricity. If you're using heat pumps in a building, why isn't it that then you're getting a lower electric rate structure? I think it's a policy objective that we should really be thinking of. Okay, so going back to the question at hand. So these house meters, almost all of our heating and cooling, all the common area lighting and all that is covered by the solar. However, the apartments have their own meters, and that covers their plug load, their appliances, and a small fan for their indoor heat pump unit. So that the latter, all those apartment meters are not covered by the solar. However, those loads are pretty small, but not small enough. So if we look at this graph, which I think is pretty helpful, you can see on your left, this is what our system would look like with no PV. So here, the green is if all of our electric loads that I mentioned. So the residence electric loads, all the heating and cooling, all of that. The only thing that is gas is that hot water. So this is what it would look like without PV. We have a 123 kW system, and this is what it looks like. So we are using that solar PV system to match the house meters down here, and then we're not tackling the residence units or that gas hot water. If we increase the size to 183 kW, we could be covering all of our electric needs for the building, including the resident tenant needs, but we still have that gas. And then if we increase to 214 kW, we would be at total net zero. This is something I think we should be aspiring for in our projects. So there's different ways we can go about it. One issue is we didn't have enough roof area to get to this. That was the first problem. However, panels, as you know, I've been doing solar since like forever, and the how much you can get, how many watts per panel is so much better than it was, like say in the early 2000s. So we're getting better every day. We can fit more and more panels onto this onto all of our projects because the watts just keep increasing. I need to note that when we started this project, we were only going to do a 100 kW system, but then Sunbug reached out and said, hey, we just got these new panels that have even better performance. We can get up to 123 at about the similar cost, and we can at similar roof area. So we're really excited. So we went to the 123. So there's the roof area issue, but we're going to get better at that. I also think if we could have found more space if we had a reason to. So I want to mention one of the big issues here is it's, as an owner, it's very hard to want to do more than your house meters. And one of the problems with it is that net metering laws. So the utilities are imposed, there's actually restrictions of how much, every utility has a limit of how much net metering they will allow on that at that utility. And to me, it just seems really wrong, really backwards. So if you get in on a project and it turns out that that utility is already capped out on its net metering limits, then you won't get paid back if by the utilities if your meter is running backwards, which I think is just nuts. So that means that it's really hard to and scary for an owner to decide to put on more solar if they know they're not going to get compensated for that. And depending on the property, it could be within like the minutes. Like if you're not using it exactly that time, then you won't get that money back if the meter runs backwards, or it can be by the month. In this project, our net metering has to do with the month. So if we don't use it that month, then you would lose it. It seems like we are under the net metering for Unitel for this project, although when we first started, it was really questionable if we were going to get in under net metering. This is another area where policies could be changed. So I want to just go back a little bit and circle back to that embodied carbon before we open it up to questions. I want to just bring up the fact that everything we do with our buildings is not free from a climate perspective, from a social perspective, and from a political perspective. Every time we do anything in our buildings, there is a major environmental and probably social and probably economic cost. Even like solar, like, oh, I saw this headline, Apple spent $850 million to build a giant PV farm on 2,900 acres. There is a massive environmental cost of making all this PV. One of the reasons why, and I'm going to say that's for PV, but I'm going to say that's for all these materials that we're doing on our projects. One of the reasons why Passive House appealed to me so much, I was one of the first people trained in it in the US. It appealed to me because it's about less. It can be about more if you're doing a lot of foam, but in general, it can be about less. We're simplifying buildings in a way, requiring less mechanical systems. It's about getting rid of stuff. And I think we need to all be moving towards a less stuff scenario, because if we try to replace everything we have right now with like renewables or anything else, we're not going to solve the climate problem. So there's this architect, Kyle Moe, who talks about this idea of forms of unequal exchange. And so thinking about, we talk about climate, but we also talk about like where all these materials are coming from. Like if you look around your house and you think about where all the stuff is coming from, you got to guarantee that some of it is coming from, could be coming from slave labor, could be come from labor that really poor conditions. There's a lot of social issues of more stuff in the world. And so I think we need to be thinking about that. This is up by where I live. I live right now in northern Vermont. I lived in the Boston area for a long time, and more recently we moved here. Beautiful area. They installed a number of years ago a giant wind farm on the top of one of the mountains here. And to do it, they had to blast the entire top of the mountain and actually flatten them so that they could get the trucks up to put in these windmills. So there's an environmental cost, carbon cost of flattening mountains. There's also a carbon cost of building the windmills themselves. And so if we're able to reduce the load by thinking smarter about our buildings, we're better off. Like renewables are really where we need to go, but how can we have less renewables? I love this quote. There were like all these like environmental activists who hated the windmills. And he said his biggest gripe is the amount of blasting that they did to level off the ridgeline. And you can actually visually see that. So we're gonna have to do this to support this lifestyle that we all have. However, can we figure out how to do less of it by thinking of our buildings differently? Same thing goes with foam. I don't think this is the solution. I think we have to think differently. And then I wanna bring up the fact too, and another reason why passive house appeals to me is that it lasts a long time. So a heat pump, as we're replacing, we need to electrify our buildings. We've got to get fossil fuels out of our buildings. So we got to start using heat pumps more. Well, heat pumps last for about 15 years. So even if we all sign up tomorrow to replace all these heat pumps and we get over the whole hot water problem, and we can do heat pumps for hot water too, we're gonna have to do it again in 15 years. That has a major environmental cost. Solar panels last 30 years. Again, a huge environmental cost. We're gonna have to replace those later. So if we can reduce our loads, we're better off. And then a building lasts 100 years. And so I'm hoping as we're doing passive house, the work that we're doing is gonna last that long. And then the death of gas and getting rid of fossil fuels, that could last for infinity. Huge goal that we should all be working towards. This is from Rewiring. Rewiring's a big coalition that's supporting electrification. They talk about this idea as if we get rid of all fossil fuels today and replace everything we currently have with electric, which is a big push, that means we have to replace 1 billion machines. And that means all our heat pumps, our cars, our washing machines, whatever, dryers, they all go electric. That's 1 billion machines. Great, it's gonna give you millions of jobs. It's gonna get everyone off fossil fuels as long as we're powered by renewables. But that's a lot of machines. Can we instead think about how do we reduce the number of machines by changing the scenario, reducing our load at our buildings, saying maybe we don't need all these cars. Let's get rid of half of them that we currently have by actually siting our projects in walkable communities. There's a massive climate, political, and social impact of making that stuff. This is a project by my house, a passive house project that my friend lives in the middle of Vermont, where it's 40 degrees below zero in the middle of winter. She has a tiny heat pump heating this building. We all know that this is possible. If this was a normal building, there'd be like all these consoles. We need multiple compressors outside. We don't need that here because she's able to do it differently. She's also able to use a small amount of wood, which is appropriate in our climate, thinking differently about, you can use electric or can you use really local wood, which can be a carbon, a zero carbon material, which actually I'm using in my house to heat it, all local wood. Okay, and then finally, there's a global warming potential of refrigerant that most of us aren't talking about. So I'm gonna say that I think we should all be leaning into the void, figuring out how do we eliminate stuff. So by building to passive house, reusing existing buildings, really reducing our load and thinking smarter about all the materials we're using and whether or not we even have to do this work in the first place. So with that said, my last, before I talk a little bit about some activism we can do around this, I want to bring up the question, and it's a philosophical question that I think is grounded in data, is how deep should we be going on existing buildings? So many of us, Hank and others, are involved in advocating for deep energy retrofits in existing buildings. Now, these are not our historic buildings. These are buildings where maybe they're ugly, maybe they don't have historic value, so you can insulate from the outside. There's other buildings like the one I showed you, which is a gut rehab, And you can get to passive house pretty, with some effort, but by insulating on the inside. So how deep do we go on our existing buildings? Some people say there should be a target. You don't have to get all the way to passive house on existing buildings. And I've been lately questioning that, and I'd be interested to hear other people's ideas. My thought lately is it takes so much effort to get into a building in the first place that why don't we just go all the way? And my logic on that is we don't have much time to deal with this climate crisis. We're only going to touch these buildings. If you look at like our 2050 plans or 2030 plans, how many times can we touch a building in that period? We can't touch it many times, maybe once. And we're going to have to compensate for all these other buildings that are going to be able to do almost nothing, because most of our neighbors won't be able to do something. So lately I've been thinking is if you're in there, go all the way. On the deep energy retrofit side, I know with my program Realize, we've been limiting how deep we go. We're saying, well, we're not going to get to passive house. However, lately I'm like, it's so much effort to replace the windows and do all this stuff. Why aren't we doing, a 0.16 window instead of a 0.26 window? Could we be using what's happening at building X to offset building Y? I think we need to be thinking, and I'm going to be doing analysis on that because I want to think about that deeper, but I think we need to be thinking about our buildings as part of a macro system. They are not, I don't think we should be doing our analysis based on a single building. I think we should be thinking about it within this bigger global macro system of how can we address climate in this crisis that we're in the quickest, most efficient, least impactful way. So with that, my last slide, before we go into questions and discussion, is I want to talk a little bit about activism. We are in a massive climate crisis. I have a whole other presentation where I can share all these nasty slides about the climate crisis. And I've been talking about this climate crisis for a really long time, like basically my whole professional career, which has been like 20 years or something. And I've been talking about it. In the last, I don't know how many years, these scary weather events are starting to catch up to us. And what we're seeing, especially in disadvantaged communities, we saw it with COVID. Disadvantaged communities are hit hard and fast with COVID. They're also the ones that are getting hit the hardest with the climate crisis. I think we really need to be focusing a lot of these efforts as we go to zero carbon buildings on disadvantaged communities, low-income housing, other forms of housing to help reinvigorate these areas that are going to be hit the hardest. So with that, there's great opportunities if you want to get more active in zero carbon buildings, and we need your help now, like this week and next week. They're really important weeks. So I work on federal policy, and at the federal level, what we've seen is that there is not enough cohesion happening with the building community. There's advocates, environmentalists, there's energy efficiency experts who are doing advocacy. There's affordable housing developers, there's others, but they're not all coming together around a cohesive list of asks at the federal level. And as a result, even though you may have heard that there's amazing infrastructure bills that are getting passed that are helping with climate, they actually don't go very deep, and it's incredibly disappointing. And after this whole reconciliation passes at the federal level, I think we all need to regroup and figure out how we can come together better so that we can have a cohesive list of acts that are going to happen federally going forward around climate and buildings. So that's at the federal level. We can talk about that, in a few months once, reconciliation passes. However, right now there's a massive opportunity to happen at the state level. The first is ARPA funding. So this is the American Recovery Act. They gave ARPA money, which is in the billions of dollars, have been allocated to each of the states, including Massachusetts. In Massachusetts, we have not done a good job in the of people concerned about climate change to advocate and say we need some of that money to support buildings and a move towards zero carbon buildings. There's a great opportunity. This last week, there was a hearing by the Massachusetts legislation where they were asking for comments on how to use that ARPA money. And we're talking about like $500 million that could potentially be used just for greenhouse gas emissions reductions in buildings, like if we advocated for it together. So there's going to be opportunity for you to provide comments. I'm hoping that Hank and others will share somewhat like a list of bullets that you could share with in both writing format and also with conversations with people in the legislation to say that we need to support more passive house projects. We need to support more deep energy retrofits. So that's on the ARPA side, and that they're accepting comments right now. I've heard that by Thanksgiving, they will have allocated all of that ARPA money to different causes. So let's get climate change up there. Finally, the other thing is the EAC. The EAC is the group that oversees the utility programs, like the rebate programs. They were trying very hard to get them to do a deep energy retrofit program that will incentivize deep energy retrofits. We need more people making comments. Hank and I talk a lot at those meetings. It would be really good if some other people are up there because everyone's getting bored of us. So September 22nd, Wednesday, there's an opportunity to share comments and we can give you some talking points for that as well. And then finally, the stretch code. There's going to be a zero, there's a supposedly in progress is a zero carbon or zero energy stretch code that communities can adopt. The draft of that is coming later this fall, and they need to hear public comments. We also need communities who are going to sign up for that zero energy stretch code, which is huge. So these are all areas where you can act today and make, I think, a huge difference on trying to address climate. So with that, I want to open it up to questions.
Okay, I've been tracking some of the questions. Can everybody hear me now? Yeah, tracking questions in the chat. So I'm going to run through several of those first, and then we can open it up further. Everybody's fascinated by your accomplishment with the windows. It's a historic accomplishment for sure. And the question is whether the window details can be shared. Tom Buckley has interjected that he can help share them, but it would be great, actually, I think, to even see the approval letters from the NPS for the windows.
I'm sorry, Hank, what was the last thing that you wanted to see?
The approval letters from NPS. It must have come in writing. So anything you can share would be of great interest to people, I think.
Yeah.
Second question was, did you do WWOOFie analysis of the project, which I assume you did, but you can answer that.
Yeah, so let me answer the first question about windows. We'll share what we can with you on what's on the windows, and maybe Tom can help. That would be, hi Tom, that would be great. And we also, I think going forward, the big thing is that National Park Service is they should be making it much easier to approve these windows. So you should be aware that if you go with one of these double hung casement windows, whatever they're called, double hung casement, simulated double hung casement windows, that is going to be an easier process. We can share that slide where we did that really tight analysis down to like the 1/8 of an inch and having to match the meeting rails and all. And that's something that as architects, I assume if you're doing historic projects, you're probably doing anyways for any of your window replacements to show how similar they are. But that's something that was like really important to getting these approved.
Yeah, I think it's great to share that, because my experience with historic projects is that there's a whole set of aluminum window manufacturers who's figured out how to meet National Park Service requirements, and they're kind of almost pre-approved by National Park Service. They are terrible windows from an energy point of view.
They are terrible, and I wanted to add to that, they're really terrible. Like if you look at the R value or the U value of those standard windows that we're using in historic buildings, they really, their performance is abysmal. And so there is opportunity to do better, and I think we should all be trying to, even though it's hard to get those approved in the beginning. I think it's gonna be much easier going forward. I want to mention that when we were looking at whether or not we could do this at Moran Square, I started looking at what other places are doing. And the New York City Landmarks Commission, which is not the same as National Park Service, but it does oversee these projects like in Brooklyn and other places with historic buildings. They actually have a one-pager that encourages you to do Passive House, and they give you advice on how to get there. And these simulated double-hung windows, double-hung casement windows, are they recommend them as being the way to go. They don't give you manufacturers, but they tell you that it's okay to use them. And I think that's where we, like all of the historic places in Massachusetts, if they're sharing something similar, it make a big difference.
That's great. That's real progress. You were going to speak to WWOOFie analysis. I presume you did.
So I wasn't the Passive House consultant. Peterson Engineering was on this project. So they did the analysis that were required. So yeah, WWOOFie was part of it. They didn't, like in terms of doing therm and looking at things, it's my understanding they had to do minimal therm analysis and other things. So, but there was a lot of back and forth with FIAS on this, especially because it's historic and there were thermal bridges. So we really tried to do our best. And then in some places, like we overcompensated for things that we couldn't do as well elsewhere. So
another question came in from Keith Lewis regarding, are you aware of, or did you consider any hot water reclamation systems where the drain water heat can be extracted and put back into the systems?
Yeah, I wish we had. I think we were, Mike Brown from, who's our Passive House rater, he recommended things, and also like the size of the pipes and other things that we could be doing that would improve our hot water efficiency. That came a little too late, and people were getting pretty risk averse after this window thing and other things. So we didn't go as far as we could have on some of that, and I would have liked to. I know I was working on a project in Pittsburgh where it was another historic project, and they were looking very seriously at those kind of ideas. And I think we should all be doing that on the hot water side.
Great. Ken Levinson has asked about a question about the embodied carbon of PV and what kind of trade-off, what kind of analysis have been done about the embodied carbon represented by a PV installation itself?
I think that is such a great question. So I saw some data because I did a presentation for our internal team where I was talking about some of this and like how we have to think about macro implications. I need to dig deeper into it. There was a study that showed up until I think it was 2007, perhaps, just from an energy standpoint, we were using more energy to create PV than we did to make it. And then after 2000, we would basically be spending more energy to make PV than we did that we were producing from it. After 2007, it showed that everything that we were making with solar PV was actually a net positive, which is good. That study didn't look into the carbon implications of the panels. It's something I'd like to dig deeper into. If other people have data, that would be great. Yeah,
it's a scary question to ask if it falls into the embodied carbon potential.
Exactly, and it's one of those things that lately I've been, not lately, but it's been going on for years, where I've been questioning our whole lifestyles. This is not as comfortable a conversation, but do we really need to live exactly like this going forward? Is there a better way to live that maybe we're not using as much energy in the beginning? Replacing things one-to-one, I don't think it's going to work.
Right.
If I may just jump in on the embodied carbon of PV question, a lot of that does have to do with where the PV is manufactured and under what regulations it is manufactured. Things like a carbon tax could dramatically affect the way that is considered. Certainly, price of PV is also a major driver. And so much of PV is made in low-cost production countries where the carbon impact is much larger. So kinds of comes back to this stuff question and how things are made, as well as where they're made.
Yeah, and like we have a lot of PV. I'm sure we're getting at low cost is probably being made by coal power plants. So we need to question all that. And also, can we bring things locally? I mean, it's really hard. People have been trying to get manufacturing back in the US forever. And we're trying to do that on our deep energy retrofit side, trying to create some of these zero carbon panels on the deep energy retrofits. We'd love to see more production locally, and it's really hard to get people to do it here for many reasons.
So Heather, I had a question about what type of calculator did you use for embodied carbon, and how did you think about in effect, an embodied carbon credit for using the existing building? And did you factor that into an overall embodied carbon profile?
Yeah, I apologize. I kind of skimmed over that. When we started this project, right now there's getting to be better and better carbon analysis tools out there. And there's also some carbon certification programs. LEED, for example, is offering like points for low embodied carbon, and others. We didn't go after any carbon certifications. We started the project, I feel like, at a time where there weren't as many opportunities for certification. And so we also didn't have money to pay for that analysis. I didn't mention that when we started this project, it had already received all its approvals and funding, and we changed the entire scope of work. So there was a lot of money that we had to invest to do things at the last minute that you wouldn't otherwise. So the result was that we did no analysis of our carbon data on the project. What we did was we worked with Jacob Rakusen at New Frameworks. He working with Chris Magwood, had done really good analysis looking at like what are those top offenders in buildings from a carbon perspective, which is actually the RMI study that just came out a couple weeks ago really verifies that data. And so we kind of hit the really challenging things that make the biggest impact. So things like concrete, trying to use wood materials, trying to use cellulose instead of foam. We also did no carpets. That was something that was really important. Carpets have a really big climate impact, not just because of the initial carbon in the carpet, but because you have to keep replacing them. So we did this kind of like top 10 list that we focused our efforts. Now, I think it's okay to do that, but there's a big problem. When you come to value engineering, which you do, especially during COVID, when the prices of all materials go through the roof, because there was no certification program, it was really easy for our contractor to say, hey, we're dropping the studs in like a 2-minute conversation, and that's the end of the conversation because the price has gone up. Now, with Passive House, he knew that we couldn't be dropping Passive House because we've told people we were going to do it. So I would strongly recommend, if you're doing a project like this, to have some kind of certification so that everyone stays in line when it comes to value engineering. Some people are driven by checking boxes. As many of you know, like if you worked on LEED projects early on when LEED just came out, for some reason, some people can get really behind like a checklist, whereas they can't get around like a general concept for like a green building. So the checklist, even though it can be tedious, can be really helpful in making sure the project gets to the end goal.
Right. So do you have any sense for how much credit you could have get for the existing building?
Yeah, so in one of those first slides I showed you, the RMI study just showed that, and I'm forgetting the exact number, but I think it was like 45 to 70% of your carbon savings can happen through reusing an existing building. So we should be reusing our existing buildings, even if they're ugly, even if they're challenging, because it's going to make a huge carbon impact.
Right. So that would be 45 to 70% of the existing square footage.
Yeah, so the embodied carbon, it says reusing the embodied carbon impact of an existing structure is 50 to 75% lower than the impact of constructing the same structure new.
Yeah, great. And just the last question on this embodied carbon, do you have any sense for what type of premiums, if any, you may have paid in making those decisions about concrete and rebar and glass? And
yeah, great question. That's something I need to go back to the team and see how things were shaking out. Pre-COVID, this was looking like easy lifts. But then once COVID hit, we were all kind of in trouble. So I have to go back and see what actually happened. I talked to the developer a few weeks ago, and he was really happy about the windows and all these approvals. But he did say it was a lot harder to achieve a lot of the low carbon given the COVID constraints.
yeah, that's the moving price.
Yeah. Certain things I need to mention though, if we weren't in COVID time, steel framing versus wood framing in a building like these, for the historic buildings is like a wash. So that's an easy thing you could usually be able to do. Cellulose insulation is really cheap. It's a great thing to do. We specified for our party walls where we have to have sound barrier. So you have to have insulation. I wanted to use cellulose. In them. I got pushback because the installation issue of like a party wall. So we used eco fiberglass with a really high recycled content, which also had very low embodied carbon. That was a wash. Some of this drywall that you can use is also a wash compared to regular drywall.
So here's a question coming up in chat. Let's see. Where we often fall back on foam in existing buildings as at foundation walls. Do you recommend design for low carbon for foundation walls look similar to the mass wall design?
Yeah, it does look really similar. We used for our foundation walls, we used I think it was a liquid applied air barrier, and then we did mineral wool. And so that was a no-brainer. Now under the new slab, we used gravel instead of foam, which is so like under your slab you want to do insulation. So we avoided foam by using gravel. And the other cool thing about gravel, which it's recycled glass, is it has the same properties as gravel. So you don't have to buy the gravel. So you've eliminated more stuff. Now, the one place that I mentioned where we compromised, and I'm still not that happy with it, is the ceiling of the parking garage. We used foam. And the issue there was it's an existing building and we used the basement as the parking garage. So our ceiling height was really low. And so we couldn't get to the fire ratings we needed and the heights and the air sealing and insulation, given that this ceiling was so low. So we ended up doing foam, which is kind of a bummer, but we did a low HFO foam, but I still didn't feel great about it, so.
Here's a question. Can you describe the basic HVAC solutions that you used?
Yeah,
you mentioned your hot water is gas.
Right.
But describe your heat pump systems or whatever else.
Yeah, so we did a central system. It's a VRF system. And then, and I probably can't say more about it because my whole focus is usually on all the enclosure measures and I don't do much on the mechanical side. So that's all I'll say about it. But Peterson did it, and you kind of know, most people know Peterson and they tend to do the same thing again and again. So I bet it's pretty similar to what they've always done. Now, with that said, I kept harassing them during the whole project about the refrigerant. We are all putting little refrigerant time bombs, which have like a massive global warming potential in all of our buildings. We're kind of like 5 years early to actually electrify all our buildings. And I think we all need to be thinking about this. Maybe we all do think about it, but the people are not going fast enough in getting rid of this global warming potential of our refrigerant. In Europe, they've changed the building codes so that you can use really low global warming potential refrigerant, but here it hasn't happened yet. There's fire risks and other things. So this has to be tackled. Like we're just like all, I feel like it's like high density foam where we like all put it in and then we're like, shoot, we probably shouldn't have done that given the greenhouse gas potential. Refrigerant is about 100% worse. It's just like people say it can be recycled, and like no one's going to deal with this. Like this is like a bomb. So I don't know what to do about it, but I'm just bringing it up. There are people at RMI working on refrigerant, but I like it has to happen like tomorrow.
Yeah. Tim, can you make a comment about VRF?
Sure, if you'll allow me. Well, first of all, I want to say, Heather, you blew me away. This is amazing. Every like broad strokes, fine strokes, amazing. What I want to say about mechanical systems.
Tim's working with RMI on our deep energy retrofit accelerator, so he might just be complimenting me for that reason.
No,
Huge opportunity
not
for
true.
deep energy retrofit for Massachusetts that we should talk about real quickly before this. So go on, Tim. Sorry.
Yes, but that's not true. I am purely. I'm at this presentation because I wanted to see the project. I frankly didn't even know you were a part of this. Okay, so
Okay.
Blow me away. You blew me away. Now, VRF, my experience and my perspective is I think we need to move away from centralized systems precisely because of the refrigerant issue, but not only because of the refrigerant issue, because my experience with centralized VRF systems is that they're extremely complicated, and when they go down, they go down. And is there a you know, if they go down in the middle of a heat wave, what's the backup for air conditioning? It's extremely challenging, not to mention the refrigerant issues and the leaks and everything associated with it. So I'm a huge fan of thinking about decentralized systems that are more affordable, because the other thing about VRF is that it's extremely expensive and extremely complicated. I'm about the exact opposite, extremely simple and extremely cost effective. And so I understand the issue with this project around, you know, through wall penetrations and all of that, because it's a historic building. And I totally get the perspective, but I really believe that what we need more than anything are manufacturers that think through this heating, cooling, ventilation, and dehumidification strategy that is more decentralized, because it's more cost effective. My experience has been more cost effective. And because think about it, when I started Passive House, people said the mechanical systems are going to be half the cost. Why? Because we're reducing the loads. And I'm like, wow, that's exciting. Guess what? It's the exact opposite. It's twice the cost, because you have a completely separate ventilation system from a heating and cooling system. So why don't we just merge them? Why don't we just find systems that can do both at the same time? And when one goes down, the entire building doesn't go down. So that's just my perspective. I'd love your experience, like your thoughts on that, but that's my perspective.
I want to add to that. I think it's a really good point. And like I said at one point in this conversation, is I'm attracted to Passive House, where I was originally, you know, like I remember Ken Levinson, you were in my class, you know, that we were like some of the first taking this class, and it was because these are simple systems. And I too was like, wow, this is going to be so cheap to do the mechanicals, because we all saw like the New York Times articles that said you could heat these houses with a hairdryer. So thinking about how to do this differently is really important. So one of the things that's been fun about working at RMI, like I said, since May, is that we just got a grant. RMI is doing all this really cool research, and we have a really good relationship with DOE, and we've been working on this mechanical pod that's like the magic box that we were all like waiting for, and that should be rolling out in I'd say a year or two. So there's going to be 2 pods. One is a pod for low-rise buildings, so you could be adding, like, for example, to the outside of the building. And it would have combined heating, cooling, ventilation, and hot water in it. And then another is for the larger, like mid-rise buildings. So that's work that we're doing right now. And I think there's going to be a great opportunity for that. And on that note, I do want to do a shout out about deep energy retrofits. As I mentioned in the beginning, I oversaw Castle Square deep energy retrofit like in 2010-ish, which was the first large scale deep energy retrofit in the US, like 192 units. So now I'm overseeing this program in the East Coast, where we're trying to do more deep energy retrofits and actually like transform the market. We are looking for projects in Massachusetts to do now. If you have any deep energy retrofit projects, Tim is part of this team. And we are looking for projects that would start construction by 2023. And so if you have a client that's interested, we have ideas of how to really do this effectively. We don't have a magic source of funding, although that's why we're having conversations about ARPA money and EAC money. So there could potentially be funding for this, but this is like really important stuff. You know, in my perspective is we have existing buildings like gut rehabs, they all should be passive house. Almost all gut rehabs can get to passive house. So why don't we do it? All new construction can get there. Why don't we do it? Now, then you have all these other buildings that aren't gut rehabs, they're occupied rehabs. So what do? You do insulation on the outside for some of them, not all. And so we're trying to create solutions for that external insulation system. And Tim and I are working together with some manufacturers to say, can we do a zero carbon panel? You know, like if we're going to do this, let's not spend a ton of energy and carbon to make these panels. We got to do a zero carbon panel. So that's something we're pushing. But please be in touch if you have a project, because we need more projects. Yeah, you can follow up with my contact info. So
okay, good. You've got that one. I just have some miscellaneous questions. You had 123 kW on your system and showed that to truly be net zero with all the consumption of the building, including the resident meters, you'd have to be at like 214 kilowatt. Right. And we know that there's a lot of movements out there right now, including some of the stretch code proposals that are pushing for net zero for the entire project electric profile. And we also know that that pretty much means that you would have to go off-site to make up the difference. And I wonder to what extent you've given that any thought about what it would take to take a project like Moran Square and have to go, I always say, go to Texas to get here.
Yeah.
The rest of you.
I think the first thing that we need to do is figure out how could we have squeezed more panels onto this building. I think we absolutely could have. So that would have got us closer. The other is, can we deal, you know, Passive House does a really good job on all the shell stuff and reducing loads, but like someone brought up the hot water question. Could we reduce our hot water more on a building like this? And we could have, like we could have done different pipe sizing, which we would have had to get special variants through the building codes, which would have been a hassle, but we did that for the windows. Why didn't we do that for the hot water? So that's an area. The idea of recycling the hot water heat, that's actually a pretty much easier thing to do. We could have done that, we didn't. And then there's the plug load. So could we have gotten closer on that plug load by actually like interacting with tenants? That would be amazing, right? Like there's a huge opportunity by interacting with tenants that can be like really positive for everyone involved. So we can reduce those loads further. Now, in terms of offsite, I think there's a huge opportunity for the grid getting cleaner, and that will have to happen through offsite infrastructure investment and, you know, solar farms and wind farms. With that said, if we don't do a better job at reducing our load, we are going to have to dramatically, in addition to doing all those solar panels, you're going to have to do tons of transmission lines. Right now in the infrastructure bill, someone did an analysis. I think we need 3 times the number of transmission lines that we currently have today if we electrify everything and don't decarbonize what we currently have. That is going to be, in my view, an environmental disaster. It's just like you're building all that crap, more stuff, lots of carbon impact of doing that, lots of impact of running it. Not to mention that, like, I don't know about you, but transmission lines like freak me out for some reason, and there's like an aesthetic problem with them. So as much as we can do within the buildings themselves, the better. However, I absolutely think we're going to have to support kind of these larger scale renewable energy farms offsite.
So nothing else in the chat? No, not right now. So I want to come back to the National Park Service with a few questions. When they limited you to the 6 inches of intervention on the inside of the walls, and was that because of reveals of window depths? Was it because of it, or was it something like they were concerned about cutting down the interior square footage?
Yeah.
What were they really speaking to?
So National Park Service is a little bit random if you've done National Park Service projects with what their requirements are. So on one project, they might tell you you can insulate the heck out of it. They don't care how deep it is. Like when we did that, Coda and I did that LEED historic project, like 2007 or something, like they didn't care how thick we made it. I've heard other projects have to like, they'll say exactly the same project has to reveal all the brick. So it can be random. On this project, my understanding of the justification was, fortunately, we already had walls that were built up with plaster lath, and then there was also beadboard. So they allowed us to push that in, but they didn't want the reveal to be too deep. It starts to look odd. So that the restriction on the 4 inches was somewhat random, I assume, but it was also in response to the fact they didn't want to go thicker because of how it would look aesthetically. And I did push them on that early on to say, we really wanted 6 inches additional. So we would have, 4 inches means we got 6 inches to play with. If we had 8 inches to play with, now we could do a much better job and actually have that strapping, and that would protect our air barrier and our vapor barrier and make installation much easier. Now, in my new role at RMI, I do a lot of advising with like HUD and DOE and others. And so a part of my plan, and maybe MPS is on this call, I don't know, but I do plan to reach out to MPS and say, hey, can we have some conversations about this to figure out how we can streamline it? Because I know that there are people on that staff that are passionate about historic buildings, which I also am. I love history, I love historic buildings, but are also want to deal with this climate crisis. And if we can streamline things like the windows, wall sections, what you can do, and this also improves the durability of the buildings. And as a side note, National Park Service loves when you don't do foam. Foam adheres to the building. It is hard to remove. If we can do other materials that don't, like have those long-term effects on the building, that's something National Park Service can get behind. And they like that about this. I've also presented this to like, Vermont Historic Commission and others. And that's something everyone's like, oh, that's so great because we hate foam. It like ruins the buildings.
So I've got one other question about historic, the National Park Service. I'm curious, what was the justification for requiring brick on the new building? My general experience with them, the philosophy is new buildings can look new and don't have to try to be old. So they wanted this to blend in for some reason. I'm curious how they were speaking to that.
So I was surprised too. So because we're in a historic district, they had lots of opinions about how this building would look. So the brick was only part of it on that new building. They also had comments on they didn't like the style of the windows we were doing. And we had to do something that looked more like a, double hung. So that was them giving us feedback based on the historic integrity of keeping the historic integrity of the area. So it doesn't have to look old, but it can't, they felt like it can't look that different. Now, I want to mention, if you have to do brick, we've done there's analysis that shows that thin brick has a much lower carbon impact and also can be cheaper. We ended up, unfortunately, I tried to bring that into the project really late, and the architect and other members of the team almost killed me because they're like, we're not going to go back and redo our entire structure. So that was too late, but it's not too late for you. There's also a product called Greenleaf brick that many universities now are using, and it has 30% recycled content. And I know that on this project, the architect was considering that as an option and was pricing it out, but I haven't circled back to find out if they were able to use that.
Okay. Well, Heather, this has been a fantastic presentation and a fantastic project, and we thank you so much for taking the time to share all of your incredible and knowledge about this project and the depth of your knowledge. And just to plug your advocacy slide, we will be posting on PHMass Massachusetts links for people to pick up potential language for ARPA letters and for EAC letters. As Heather indicated, we are literally in the next 10 days, we have a window of opportunity to exert whatever additional influence we can. It's not to say we'll get everything we want, but it's our opportunity to once again try to influence how these funds get allocated. So encourage people to go to our site, pick up what you can and submit letters. And if you can show up for a hearing, like at the EAC, as Heather indicated, an insider told me they like us, but they're getting a little bored with us because
Yeah, and I need to say too, like, I see who's left on this call. You guys are like the hardcore ones at 7:30 at night that are still on this call. If you guys, if it was only all of you that talked to the EAC and wrote a letter and then also wrote a letter to ARPA, that would make a really big difference. So this is not a joke. Like, this is not like sign your name on this thing and it might help like down the road somewhere. This is like real money that's available now that could improve deep energy retrofits, get more passive house projects built. And like it's like at our fingertips. We just have to advocate for it. So it's super easy. Hank will share the information, like just do it. It's like a good thing to do. Then you can have your dinner afterwards.
All right. Thank you very much. I'm going to wrap up this meeting here. It's been fantastic.
Yeah, totally agree.
Thank you, everybody.